Hey everyone, welcome to another video where we'll be talking about the software engineering content which I have created in past 2 years. The content which I'll be talking about is purely around software engineering and senior engineering content basically. So I'll be talking around the data structures and algorithms, low-level design, distributed systems, and system design basic concept. So all the content which I'll be talking about is open source, so you can easily visit the link, visit my portfolio link, visit my YouTube channel, and you can download the content for free, or you can watch the videos for free on that particular platform. So all the content which I'll be talking about will be open source, and we'll be talking about all of them one by one. So we'll be starting with data structures and algorithms. We'll go through the content, right? After that, we'll go around the low level design. We'll be talking about some software engineering handbooks which I have created in past 1 year, right? We'll go through the PDF. I'll show you how to download them by going on my portfolio link. I'll go through my distributed uh, series 101 which I'm currently covering on my YouTube channel. So currently this is my GitHub profile, and if you'll scroll down you will find some of the repository. So the first repository which I'd like to show you is my DSA template, that is like Saurav's DSA template. And if you'll go through this, if I like click on this one, then you'll find a collection of data structures here, right? A lot of data structures along with some algorithms as well. Some algorithmic standards like dynamic programming is here. You can find graph concepts, you can find some data structures like binary heap, you can find algorithms like binary search, again some data structure binary tree, and so forth and so on. And if you will go through the readme here, you'll find the supported data structure which is currently like present on this repository, and some of the algorithms which is also covered under the repository. So it is currently a vast list here, and I'm continuously adding more and more algorithms and data structures here on my repository. And the good thing about this repo is that whatever data structure or algorithm I'm trying to cover on my repo, or I'm putting on my repo, I'm trying to validate it through some lead code problems. So why I'm doing so is because I want to validate that whether whatever data structure or algorithm I am implementing can scale or not. So I can do a basic implementation of some data structure, but it does not make sense if that implementation does not scale, right? And here is where lead code problem comes up. These lead code problems helps me in running my data structure or algorithms on a wide variety of test cases or in a huge test cases. So if my data structure algorithms, if I can plug it in and uh, build my solution using those data structures and algorithms, and if that solution passes all the test cases, then ideally it validates that my data structure algorithms which I have put here on the repo is valid or correct, right? It will work. So that is the essence of adding some lead code problems here. So whatever lead code problems which I have added here internally uses my data structure which I put here in my repository. So whatever data structures which you are finding here in this list, all of these data structures, or sorry, whatever problems you are finding here on the list, all of these are lead code problems, and all these problems uses my data structure which I have posted on my repo. So it internally validates that my data structure, the implementation of my data structure is optimal, right? So suppose for an example, if I can go through this binary heap, this comes up. So you'll find the implementation of the data structure here. So if I go to the binary heap, you can see this data structure is here with the methods, and along with that there are some other implementation of binary heap, right? Essential implementation, this binary max heap we have here, and this is binary min heap which we have here, and some class design for binary heap. So all of these classes together form a binary heap data structure. And I have also put one problem here which is top key frequent elements. It's another lead code problem. If you'll open it up, it uses my data structure. So if you'll see here in the import statement, I have used binary heap, right? The binary max heap which I have used is picked up from my previous package which I showed, right? And the heap node as well which you showed earlier, right? And yeah, so this is the lead code problem, and this is the solution here. And if you'll go to top key frequent elements here on the list. Okay, let me find it here. Top K elements. Yeah, here it is. So if you will see, uh, it will open up the problem. I'm not sure I have logged into it or not. Okay, I haven't logged in, so it won't show the solution, but yeah, if I have logged in, I would have shown you the submission time, but here also I have written the top key frequent elements, and I have used that particular solution which I showed you earlier, and that solution has passed in 17 milliseconds. So it ideally shows that whatever implementation of binary heap which I have put on my repo is optimal. Yeah, it is worth learning actually, and you can actually solve some competitive programming problems using that data structure. Same goes with, let's take another example of disjoint sets. So it's also another advanced data structures, and if I open this up, click on this. Okay, so if I open this up here, you will see disjoint sets as Java, right? Disjoint set dot Java. Okay, yeah. So here it is. So here you can find this implementation of the disjoint set data structure. Along with that, there is one problem as well. A number of provinces. So here also I have used, if you'll find this import statement here, it shows that the disjoint set data structure which I have used in this problem is picked up from my repo, right? It is from the same package, right? This is the disjoint set .java class which I have picked up and used my lead code solution. So again, if you will see here in the top k provinces, or number of provinces, I guess, yeah, number of provinces here, you can see that I have used that data structure and my solution has passed in 2 milliseconds. So again, it shows that the implementation of disjoint set which I have done is worth learning, or it is an optimal implementation. And so forth and so on. You can find multiple data structures and algorithms in the same way here, and whatever data structures I have used, I have like tried to solve one or two problems related to it, one or two lead code problems related to it. And for those lead code problems which I have put on the repo, you can go through the readme and you can find that whether I was able to solve that problem or not, and if I was, then what are the tags or what are the data structures which were used, and what was the runtime of my solution. So these are the information which I have put here. I'll continue to extend this repo for like to involve more and more support of data structures algorithms, so that it should become an exhaustive list. Now currently we are on my portfolio website where I have accumulated all the content which I have created so far. So this is the low level design CDs page where you can find all the low level design or the design patterns which I have covered. So basically I have a newsletter called Systems at Scale where I used to put all these content on distributed systems and system design. So there is another low level design series which I am running on my uh, newsletter, right? And these are the additions. So I have like accumulated all the low level design, like all the episodes which I have covered in low level design series under on this page. So if we go through this, so there's an introduction basically, and there's the course outline or the series outline here where I have modules. So every module covers one design pattern. So if we start with singleton pattern, then decorator pattern, factory pattern, command pattern, observer pattern. So this is like not a full list. So currently till module 5 I have mentioned it here, but apart from that I have added two more design patterns. I guess one was the facade pattern, and I don't remember the name of the other one, but yeah, I have added two. Oh, sorry. Another one was the strategy pattern. So just observer pattern. After that, I have added strategy pattern and then facade pattern recently. So these are the 7 design patterns which I have covered. And if you will see, you will find two links here. One link is to start the module, and another one is the code link. So let's. I'll first go to the start module link, right? And if I go here, this is nothing but the LinkedIn system design, that my systems that scale newsletter page here. And you can see this low level design part series part 1 singleton pattern. If you'll scroll down, you'll be able to see the content which I have put here. So you can read through this. This is a pretty detailed explanation of each and every design pattern along with the code walkthroughs. So whatever code which I have written, I have posted the code snippet here for a better understanding. And same goes for all the other all the other design patterns as well. Now apart from that, you will also find the code link here. So this code link is nothing but it will direct you to my LLD template. So it is another GitHub repo here. So if I'll go to my GitHub profile, so you can see, okay, let me go to the profile. So here on my profile, you'll see this sort of low level design template. If you'll go on it, right, you'll see the design patterns which I have covered here. So I told you that like I have covered two more design pattern, that is the facade pattern and the strategy pattern, which has been mentioned here, that it is the facade pattern and this is the strategy pattern. Along with that, there is a readme where is a documentation of the repo where you can find all the design patterns along with their different code implementations. So for a single design pattern, for a single design pattern, I have tried out multiple types of implementation. So for example, for singleton pattern, you can find three type of implementation. The first one is the lazy implementation, then synchronized implementation, and then the eager implementation. Now if I click on this, you will be directed to the code of it. So you can see the code here. Along with this code, you have to like run this particular code, right? So you can find a runner class as well. So this will have the main class. So what you can do is that you can like clone this repository, download it on your local machine, and then you can compile this singleton pattern um, package, and then you can run this runner class and you will actually see this singleton pattern in action. What you can also do is that you can like tweak this cache service, or you can like create your own service or module that can implement a singleton pattern. And same goes with all the other design patterns as well. Like for every design pattern, you will find the code here. So suppose if I go to the factory pattern, like there is a newsletter example, there is a design book example, right? So if I'll go to the newsletter example, I'll say this, you'll see three implementations here, like this, the factory method, inefficient, and the simple factory pattern. So if I'll go to the simple factory pattern, you'll again find two classes here and a runner class. So basically runner class is basically where the main method lies. You have to run this in order to see this design pattern in action, right? All the code resides here. So what you can do is that you can simply like uh, clone this repository and put it in your local machine, and you can compile this package, and you can run it, and you can see this design pattern in action. So what I have covered here is that along with the detailed explanation of the design pattern, you will also find the code implementation as well, which you can actually clone into your local machine or download into your local machine and run it and see it in action. Or you, and also you can perform an edit on top of it, and you can like make your own version of the design patterns or own examples of these design patterns. Here we are on my software engineering handbooks webpage. So it is again, we are on my portfolio website, and there is another link to my software engineering handbook which you can find on my portfolio link. So I'll link my portfolio website. It's very simple, sort of pratik.me, but I'll still link this on this description of this video, so you can get that from there. So it's when you come here, you basically find this intro software engineering handbook. It's basically the collection of all the software engineering handbooks which I have published. So to give you a brief introduction, what are these? So these are basically the handbooks. You can expect this to be 30 to 50 pages handbooks, which will be covering a particular topic or a collection of topics. So that can be around distributed systems, system design, low-level design, and related software engineering and data structures algorithms as well. So you can find for distributed systems, you can find specific subtopics like around transactions or around replication. Around maybe in low-level design, you can find a couple of low-level design or design patterns, or you can find a particular software system design concepts, right, or a particular data structure algorithms, right. So if I scroll down, so I have around 10 to 11 handbooks currently published on this page. So if you'll go to the handbook, you'll find the description, what are the things which you can find in this handbook, along with an explore page. So this explore page is nothing but the drive link to the PDF of those handbooks, which is currently open source. So if you can like simply click on the explore button, you will be directed to the drive where you have a view all permission. So it's basically anyone can go to the explore, anyone can click on the explore link and view the PDF or download that as well. So this is the basic gist. So suppose this handbook contains a lot of content here, right? It's around 50-page handbook. So a lot of things to cover here. You can go through it. If I'll go through all that handbook, so this is basically the low-level design handbook part 1, where I have covered 4 to 5 design patterns inside this handbook. This is again a distributed system, basically the transactions subtopic, which I've covered under the distributed systems. So you can find this. Again, you can find this content related to transaction, distributed transactions, concurrency control, isolation levels, and all within this handbook. If you click on the explore page, it will again be directed to the drive link where you can find the PDF of this book. It's again a 30-page handbook, where in the content you can find all the content which you can expect in the handbook. Right, pretty detailed. I have like a lot of, you can find a lot of diagrams and illustrations on this handbook, so that I have made sure that it doesn't bore the audience to keep the books interactive. I've tried to add illustrations, diagrams as much as possible, like try to make it as much visual as possible basically. Again, another topic, partitioning in distributed systems. It's another handbook which you can find here. Similarly, replication in distributed systems, another handbook. Foundational concepts in system design, right? This is currently a 2-part handbook. So foundational concepts in system design part 1, and this is the foundational concept in system design part 2. Again, data stores behind the database is another interesting handbook to cover, which basically covers all the internals of the databases, all the data structures, algorithms which powers your databases. So it involves log structured merge trees, B trees, hash indexes, and all. Again, another handbook around data structures and algorithms. So it basically covers the shortest path algorithms. So a brute force approach, Dijkstra's algorithm, cycles in the graphs, and all. Again, another handbook around data structures and algorithms. It covers disjoint set data structure, right? A detailed explanation along with runtime analysis and stuff. So again, if you click on this, you'll go to the, like it will be directed to the drive link of the PDF, where you can find this data structure, all about the data structure and like the algorithms and stuff here. So yeah, nice read to do in your free time. A lot of content is here, and yeah, you can simply like go to my portfolio link, which is mentioned in the description of this video, and yeah, you can go to the Software Engineering Handbooks page, and you can go to the PDF through the explore button, can download it, or you can read it. So here again we are on my portfolio website, and there is another page which you can get directed from my portfolio website. It is around system design 101. So 101 means the basic concepts under system design. So what I've done is that whatever content which I have created under system design, I have enlisted it here. So this will basically direct you to my newsletter editions. So I have posted a lot of content around system design under my newsletter, Systems That Scale, and these are all these editions here. So the system design specific editions are listed here. So basically the first thing is the intro, right? Covering like course involves in-depth explanation of the concepts like load balancing, caching, and stuff. And if you'll go to the module, you'll see the first is the getting started with the system design or the introduction. Then you'll find load balancing, then caching, database sharding, consistent hashing, microservice monolithic architecture, and cracking the system design interview. So 7 modules are here currently listed. I'll extend this to more topics as well. And if you click on this link here, it will again direct you to my newsletter article. So so this is caching involving your architecture. You can find the entire content here, along with like I try to like make my content interactive through flowcharts and diagrams as much as possible, so that it does not bore you, the reading material does not bore you, right? So you can find these content here, and this like involves for each and every module. So all the modules which are listed here, there is a start module button which you can click on it, and you can be directly directed to the particular newsletter edition, and you can read there and then like refer to that content. And the last content which I'll be covering is finally the distributed systems 101 series, which I am currently covering under my YouTube channel. So this is my YouTube channel. Basically, you can like if you'll go through it, you'll find a couple of videos. So it's been 1 or 2 months since I have created my around 1 month since I have created my channel, and these are the 6 to 7 episodes or 6 to 7 videos which you can find under my channel. So if you'll go to the playlist here, you'll see the distributed systems 101 series. So if you'll go to the click on the view full playlist button, you will find the episodes here listed in this series. So basically what I'm doing is that I'm trying to cover the foundational concepts of distributed systems from scratch. So even if you have a basic computer science knowledge with no industry experience as well, you can still try out this series and you'll still get to learn a lot from it. Each and every episode is pretty detailed, lengthy as well, so make sure that you have some time when you start binge watch this series, right? You can expect the episodes to be around 30 to 40 minutes of length, and that's why like you should have some spare time when you are trying to watch this. So currently I have like 5 episodes and one introduction episode here under this series, right? It's basically around replication and transactions currently, but I'll be covering like more episodes inside this series as well. Probably I'm aiming to like put 1 episode per week or 1 to 2 episodes per week at max, so that like at the end of this series I am trying to have around 15 to 20 episodes under this, so that we can cover the entire foundational concepts of distributed systems from scratch under this single series. So yeah, that is the like end goal of this DS 101 series. So yeah, that was it. These are the software engineering content which I have put on to the community in past 2 years. So if you like guys found this insightful or helpful, then do visit those content, do like this video and share it with others who can get benefited from these resources, plus all the links, all the like content which I have like mentioned here in the video or shown here in the video. The link to all those content is there in the description of this video, so you can find it out and you can go through all of them.